G'day there everyone. Today we're going to do a video on quadratics of this form. Now we've done two other videos recently. One was on the turning point form and one was on the intercept form. This is generally called the expanded form, standard form, doesn't really matter the name. We can grab a bit of information from here. We can grab the shape, very similar to everything else. Remember that the A value, if it's greater than 1, we're talking about a steeper graph. If it's still positive but less than 1, we're shallowing the graph out. A negative then does the same, flips it the other way. So this would be something that would be negative, say 0.5, negative 1, negative 2, negative 3, getting steeper as we go. Okay. Now that term steepness, be careful with that one, because being a quadratic, the gradient is always changing across the graph, but you get the idea of what we're talking about the shape. This one here at the end is still going to be our y-intercept, because think about this, if x is equal to 0, then both of these terms, regardless what a and b are, will be gone. Y will equal the c value, therefore that'll be our y-intercept value. So c on the end here is always going to be our y-intercept because these two terms cancel out. Now this b value in the middle, it's not really all that useful, and we can get some idea from it, but it's not great. So we generally don't drag much information from here. We know the shape of it, we know where it crosses over the x-intercept, but that's about it. Okay, and we can start to do some graphing. We'd use either factorise this into the intercept form, complete the square into the turning point form, or what we would do is we would use the quadratic formula, which we'll come to in a little while, to find the x-intercepts. Okay, so this form is not particularly useful, alright? But what about if we were given some information in a table like this one here, and we were asked to write this here? Where would we go with that? Well, here's an example, and let's do this example first, and then I'll come back to the main example here. Work out the difference here. The difference is going to be 3. This one minus this one. Difference here is going to be 5. Difference here is going to be 7. Now what is that telling me? Well, if the first difference is constant, I know that would be a linear equation. Now clearly the first difference is not constant, not linear. That's all that tells me at the moment. But hopefully you can see when I do the second difference, it comes out as 2. Now you might go, well, okay, great, it comes out as 2, but what does that tell you? Well, these numbers, and we'll come into this in a minute, these numbers are the important ones. They will actually help me get my formula in this format. But I don't just want to tell you what those numbers do, I want you to see it. So come back to our generic equation for this form. And if x is 0, if I took 0 and put it in there, and put it in, whoops, not there, I put it in there, then can you see those first two terms would cancel out? So when x is 0, y is just equal to c, isn't it? Okay, so let's put c there. When x is equal to 1, do the same idea. If we put 1 in here, 1 in here, can you see that I will get a plus b plus c? Because 1 squared is 1, no negatives or anything in there, fine. When x is 2, can you see that this would be 4a plus 2b plus c? 4a plus 2b plus c. And then hopefully now you can see where I'm going with the third one. This is going to be 9a plus 3b plus c. That makes sense? I'm just taking the x value, putting it in there in terms of a, b and c, seeing what I get out. Now of course these are just variables, they would normally be numbers. But I want to know what's happening so when I do this I can straight away see why I'm doing it. What did I do? I worked out the first difference. So with these two here, these two here, these two here. Now I think when we're working out the difference, it's actually the second number minus the first one, isn't it? The third number minus the second. It's x equals 1 minus away x equals 0. Okay, or really it's the f of 1 minus the f of 0, the function of. So this one minus this one, that's going to leave me with a plus b, because really it's going to be a plus b plus c minus c. The second one minus the first one. So this would just be equal to a plus b here, wouldn't it? That part makes sense? Yep. Here, it's going to be this one minus this one. So 4a minus a is going to leave me with 3a. 2b minus b is going to leave me with 1b or b. C minus c, gone. Let's do the next one. 9a minus 4a is going to be 5a. 3b minus 2b is going to be b. C minus c, gone. So my first difference, I'm just going to rewrite this one so it's a bit neater. The first difference is not constant. Because in order for that to be linear, all these would have to be the same, but they're not. So like over here at this point, I know it's not linear. Let's do the second difference. This one minus this one, 3a minus a is going to be 2a, b, gone. 5a minus 3a, this is going to be 2a, the b's are gone. Can you see how here now we've got a constant second difference, which that kind of makes sense because I started with a quadratic and I know quadratics give me a constant second difference. Now remember I said these are going to be important? Well, look at them. 2a, a plus b, c. So that would mean that this number right here is equal to 2a. So if 2 equals 2a, then in this case a must equal 1, mustn't it? So I've got my a value of that particular one. Now if then this second one up, I know that it's a plus b, but I already know a. So if a plus b is equal to 3, then b has to be equal to 2, doesn't it? And the one directly below the 0 is 5. That's c. So c has got to equal 5. So if I took those values a, b and c, put them into here, that would then give me the quadratic equation that describes this here. And then of course if you want to, put it in for 3 or 2 or something like that and make sure that the numbers actually work out. I might just do that to check. Let's write here y equals, so it would be x squared plus, I think I might have made a mistake here, this is not seeming to work out so well. Oh gee, this is not looking so good for me. What have I done wrong here? Because this doesn't look like it's going to work out.
It does.
It does? Let's see. 2 in there, so that's going to be 4. That's going to be 4, that's going to be 8. Add the 5, 13, I like that. Let's put 3 in. 3, 9, 6, that's 15, add 5, 20. No, it does seem to work. Seems to work. So that looks like it does describe the pattern that I've got. So, quick sum up. What are we doing? We're recognising that if we're given a table of values and asked to write a formula for it, do your differences, recognise that these numbers, and be careful, it's the ones starting directly below the 0, right? You can't be working here and trying to make these ones work. That won't work. It's got to be directly below the 0 and then follow the line down. You'll be able to get your A, B and C values. You'll be able to write your equation. Then you'll be able to do other work with it as well. But this is where it comes from. This idea here is where it comes from. So that's kind of just a little intro there about this format. Not the most useful format. The other ones are better. If you can factorise or complete the square, that would be my recommendation. But sometimes you're forced to work in this format, so we need some skills for it. Hope this video helped. Catch you later.